Welcome students. Welcome to the course of Mechanics of Fluids. Myself Sanjay Manuel, Assistant Professor Rajagiri School of Engineering and Technology. So I will be handling this course for this semester. So in this class we will understand the need of this, why we need this to study this course, and we will understand some basic concepts in mechanics of fluid. We engineers one who transforms our idea into reality by using universal laws. We utilize the available resources and change it into useful technologies to ace our needs. So that is the main aim of an engineer. So he will be transforming an available resources into a useful technology with the help of some universal laws. As an example, if you take, we were having steels in the previous stages. We were having steels, then we were having rubber. We actually converted the use of steel as well as rubber, and we transformed that one into a useful form. One of the example is automobiles, which will be using our travel requirements. Actually, engineers transformed the resources, that is steel and rubber. As an example, if I am taking steel and rubber into a useful form which can ace your needs. Now for this, when you are going to design such a system, or when you are transforming a available resources into a useful form, for that you need to know the behavior, how this different matter behaves at different conditions. How will be understanding that how it will behave, how a matter behave at various conditions. So how will you study? So for that we are having a field called as mechanics. Mechanics is a field, or it's an area of physics which concerns with the behavior of matter, how it moves at different conditions, or how it behaves at different conditions. So in general, if you search websites and so on, you can see a definition like this: area of physics concerned with motion of macroscopic objects. So with this macroscopic objects in general, we can define it for different matters. As we know, matter, we can take matter into three different forms: solid, liquid and gas. Can you tell me what is the difference between solid, liquid and gas? Can anyone tell me what is the difference between solid, liquid and gas? Yes, as you thought, solid, liquid and gas, it differentiate based on the intermolecular attraction between the atoms. So if we take intermolecular attraction for solids, it's very high, so that's why it is closely packed. But whereas if you take the case of liquids, liquids are comparatively, the intermolecular attraction is comparatively less. Intermolecular attraction is comparatively less for liquid compared to solid. So that's why it's free compared to solids. So intermolecular attraction, since the intermolecular attraction is comparatively higher for solids, it is closely packed and it will be having a well-defined shape. But when you take the case of liquid or gas which is much more having comparatively less intermolecular attraction compared to liquid, but in both the cases, the gas as well as liquid will not be having a definite shape. It will be taking up the shape of the corresponding container which you take into consideration. So that's why we can take the way in which the solid behaves is entirely different from how liquid and gas behave. So that's why for studying purpose, the basic phenomena that undergoes for solid and liquid, it can be of liquid as well as gas can be entirely of different types. So we can classify liquid and gas into a single field. We can differentiate solid as one group and next one liquid and gas as a separate group, which is called as fluids. So in this course we will be understanding how liquid or gas behaves at different condition. It can be in the stationary condition, static condition, or can be moving condition. Both the case we will be taking into consideration. So in this course we will be understanding how fluids behaves at different conditions. So that's called as fluid mechanics or mechanics of fluid. So this is what we will be learning. in this course. Now mechanics, as I already explained, mechanics is a mechanics is a area of physics which concerns with behavior of matter. Now if you take the case of behavior of matter, so as I already explained, it can be classified mainly into two types. First one is statics and second one is dynamics. Statics deals with bodies which are at rest and dynamics deals with bodies which are under motion. So if you take the previous phase, we classified into two different matter into two different form. One is solid and liquid. So that's why the mechanics, the science that deals with the behavior of the corresponding matter. So if we take the case of solids, it is called as solid mechanics, and if it deals with behavior of fluid, it is called as fluid mechanics. In fluid mechanics also we are having fluid statics as well as fluid dynamics, where in fluid statics we will be studying the fluid which is at rest. One of the examples is, if you take a glass filled with water which is at a stationary condition, it's a case of fluid statics. The behavior of that one will be entirely different for a case where the fluid is in motion. One of the example, water flowing through a river, it's an example for fluid dynamics, where we will be learning how it behaves at that flowing condition, how different properties or parameters vary when it is flowing, how individual forces is influencing it. Such things is being learned in fluid mechanics. Now, so in order to first of all differentiate between solid as well as liquid, we need to first understand a simple term called as stress, which we have already learned in the previous classes. We have understood what is stress. What do you mean by stress? If you take a body and give an external applied force on that corresponding body, say if I am giving some tension force, if I am taking a rubber band and giving a tension force on that one, the body within the body itself will be inducing an resisting force, and which will be pulling it inwards. Actually it will be trying to pull it inwards. Okay, now this resistant force per unit area is defined as stress. So it can be of two different forms. It can be normal stress as well as shear stress. This terminology I have already learned. I'll just refresh the things which you learned. Okay, now the stresses can be generally classified into three forms: tensional stress, compression stress and shear stress. As you know, the tension stress and compression stress are examples of normal stress, and shear stress is a tangential stress. So here it will be acting normal to the area, and here it will be acting tangential to the area. Now how we will be understanding that? Say if I am taking a surface like this, a small surface which is with, I am taking a small area dA. On that, if I am assuming that the force acting on that one and a resisting force is been induced on the body, and let it be acting like this, force F. Let it be acting as force F. Now if I am resolving its component into two components in the perpendicular direction as well as in the tangential direction to the surface, the tangential component is called as Ft, which is the tangential force acting, and Fn, which will be the normal force acting. So the normal stress will be the ratio of normal force divided by the area. So here the area is dA. So usually the normal stress is sigma is equal to Fn divided by dA. In the case of fluid statics, we will be usually having only normal stress. We will not be having a shear stress because the fluid is not moving. Now when you take the next one, shear stress, which is the tangential force divided by area, which is defined here. Now we will be defining the solid, or we will be classifying the solid and liquid or fluids entirely based on how it behaves when it is been undergone a tangential force. So here you can see solids as well as liquids. The differentiation between solids and liquid is that if you take, say for example, if I am taking a solid body which is placed in between two different plates. Similarly, I am taking fluid. It can be both gaseous as well as liquid placed between two plates. And if I am assuming the bottom plate is been fixed, and if I am giving a force, a tangential force. Here you can see this is the surface, and with respect to the surface the force is tangential to it. So that's why you can define this one as a tangential force, or we will be assuming that it induces an shear stress. Shear stress on this corresponding plate. When that happens, actually if you take the case of solid, if you deform it, okay, if you deform it, it will be changing its shape. Okay, it will be trying to change its shape. If it is within the elastic limit, once you remove the force F, it will be trying to regain. Now if you are giving force more than the elastic limit, what happens? You will be having a permanent deformation. Once you release the force, it will be having a permanent deformation. And once you release the force, you can't see any further deformation on the solid. But in the case of fluids, it will not be the same. If I am giving a tangential force on this plate, top plate, you can see the fluid will be deforming, and even if you remove this force F, the fluid will be continuing to move. So there is a basic differentiation between fluid as well as solid. In solids you will be having a finite deformation, and in the case of fluids you can have continuous deformation. Or in other words, fluid can be defined, it's a matter which under the action of external force or tangential stress, it continues to deform, which is called as flow. Okay, so it can be elastic under a limit, it can regain its shape within a limit, but here once you are given the deformation, it will not be having any regaining back to the initial phase, so it will be having zero memory for that, so it will be inelastic throughout the motion. Then here the stress is directly proportional to strain. Based on Hooke's law, stress is directly proportional to strain, but in the case of fluid it's different. Stress is directly proportional to the strain rate, the rate at which the straining happens. Okay, the stress will be directly proportional to the strain rate, which we will learn how we understood that. We will learn later. Coming to the next phases, we will be learning it in detail. Okay, the next one. So as a whole, we can define fluid is defined as a substance that deforms continuously when subjected to shear stress. However small it is, it can be a small tangential force that you give, but still the substance continues to deform. Such substances are called as fluids. So that's why liquid and gas will be having the same behavior. So that's why we define liquid and gas as fluids. Okay, next we will understand why we need to learn fluid mechanics. Actually in this course we will be understanding the basic working principle behind fluid mechanics. Since fluid mechanics is widely used in many areas in our day-to-day life, ranging from vacuum cleaner to supersonic planes. A simple example, if you take, for example, fluid plays an important role in our human body itself. Our heart, which pumps blood continuously through our veins, okay, through our blood vessels. Okay, the flow of blood, sometimes it may be impure blood which will be coming inside, and the pure blood has to be pumped outside. So the properties of the blood which comes in and comes out will be entirely different, and the pumping rate must be constantly controlled, and this is automatically controlled by the body itself. And if any problems comes up in the flow, there can be problems happening for the corresponding person. He may be becoming a sick person due to that. So in some cases, sometimes even we have to replace his heart. So in such cases we will be using artificial heart. So for designing of artificial heart, we need to understand the basics of how it works, how the fluid travels, or how the fluid behaves at different conditions. So such details we are going in, we will understand in fluid mechanics. Another example, the lengths. In that, through the duct, the airflow must be properly studied. Say for example, those who are having breathing problem, they may be using inhalers. So there will be giving inhalation. The inhalation, the particles must be reaching our lungs. So the particle size must be, the interaction of the fluid and the particle must be in such a way that it must be passing through the lungs at proper locations in order to avoid the blockage of airflow. So such things, even in our daily life, the pipe systems, pipe duct systems, or if you take any big holes and engineer, if you take our own engineering college, we are having piping systems, sewage systems. Such systems we need to understand how the fluid element transportation happens for properly deciding that. Even our automobiles, automobiles, in some automobiles, the resistance, the time taken for picking up speed from one speed to the next one, it's not just depending upon the engine performance, it will be also depending upon the shape of the corresponding vehicle which you take. Say for example, if you take our Maruti cars, it will be having some structure, but if you take an F1 car, it will be entirely different from that. The requirement of F1 car is must be moving with very high speed without causing any high temperature heating. But whereas in our cases we will not be going through that much high speeds. So the structure is made according to that. Say if I am taking for F1 race, if I am taking my vehicle, it won't reach that because it can't attain that corresponding speed. It's not because of the engine, the structure of that one will be restricting that. Since in commercial vehicles drag will be comparatively higher compared to the F1 race cars. In F1 race cars the drag must be compared very less, so that it can take a speed at very small time and can withstand that corresponding speed throughout its motion. So in such cases we need to learn how the fluid interacts with the vehicle. Then if you take ships or aircrafts, in all such cases the interaction of fluid comes up. So there all we need to understand fluid mechanics. So these are some of the fields. I'll just show up some of the fields where the importance of fluid mechanics comes. Human body, in heart as well as lungs. In atmosphere, how the weather, even the weather forecast, some of the aspects of weather forecast comes from fluid mechanics. How the fluid moves or the chemicals moves in a chemical plant. Okay, its interaction with the pipe walls is much important when you take fluid mechanics. So when you take the industrial applications, the heat transfers, in some cases heat generated will be very high and we need to remove the heat. In order to do heat transfer we need to have proper understanding of fluid mechanics, how the fluid flow through the duct. Then as I already explained, F1 cars and all automobiles. Then aircraft, in all such cases we need to understand the fluid mechanics. Now the core objectives. The core objectives of this course are, first of all we need to study mechanics of fluid motion. Then next one we need to establish a fundamental knowledge of fluid mechanics so that we can address different problems encountering in different applications. Then we must be able to familiarize relevance of fluid dynamics to many engineering systems. As I already explained, we need to understand the fluid dynamics happening in the blood vessels in order to understand is there any block happening in between the blood vessels. For proper understanding of that one we need to have a relevant understanding on fluid dynamics of their corresponding systems. Now going on to syllabus. Syllabus consists of, first we will be understanding the fluid properties. What are the fluid properties which are used to characterize the fluid which are in motion as well as in stationary condition. Then we will study fluid statics. There will be understanding the basic working principle behind the fluid at rest. Then we will be studying kinematics of fluid flow. Then we will be studying dynamics of fluid flow. Then we will understand how the flow happens through different pipes. What are the influencing parameter for that? Then we will be understanding the concept of boundary layer. Then we will be going through dimensional analysis and hydraulic similitude. So these are the reference textbooks that is being utilized for this course. One that is being highlighted is being the one which I prefer for you. So these are some of the reference texts you can use, both textbook and reference textbook. If possible, you try to buy a copy of the book textbook.